Alright, let's get started. As an example, we use Finnair. So Finnair is able to travel to Asia quite much faster than other European companies, and its strategic objective is to double the Asian traffic by 2020 from the 2010 level. So the faster travel gives it a great competitive advantage. So it's not that the airplanes of Finnair would be faster than the airplanes of other European companies, it's just that the location of the Helsinki-Vantaa airport is very well positioned to fly to Asia. To implement the strategy of connecting Europe and Asia, you buy new airplanes. And then you select the new destinations. So what kind of criteria should we choose? How can we choose the best destinations where we know so little about Asia? This is where big data comes into play. This is where we use network theory. On the left-hand side, you see a representation of the flight network of Europe. On the right side, you see how networks are depicted in scientific literature. The dots are called nodes, and they represent in this case the airports. And a line between two dots would mean that you can fly between these two airports. There is a connection between these two. So the major finding of network research is that networks are not built randomly. Some nodes are more important than other nodes. These can be identified from these kind of maps. Some airports are more important than other airports, and these can be identified using these kinds of maps. Most airports would be of the kind shown with the red arrow, so they have only a few connections. Airports like Turku, like Oulu, like Jyväskylä. Then we have the airports depicted with the green arrow. So this is a clear minority, there are not so many of them, but they are very important for the function of the network and very important in general. So these ones are airports like London Heathrow, like Frankfurt. So the ones shown with the green arrow are different from the ones shown with the red arrow. So here you see an equation that shows how fast an individual airport is expected to grow. So it may look complicated, but all you need to know is that the number of connections is marked with a K. So this tells you that the airports that have a lot of connections will grow faster than the ones that have only a few connections. So because these are so important for the network, the green ones are the ones where you would expect to have the business life, where governments want to put their infrastructure money, where you have other logistics like railways and such, where you have the cultural centers, where big global companies will put their global headquarters, and so on. So then we have the red ones. So if you would be likely to close any airport down, it would be of the red arrow kind. So you are likely to shut down places like, I don't know, Kuopio, more likely than Helsinki. So things associated with these ones are woods, agriculture, and maybe sunny beaches. So nothing wrong with the sunny beaches, but Finnair is not the cheapest airline in the world, so it would like also to have some business travelers, and business is associated with things depicted with the green color. So as a summary, we want to have the new destinations to be of the green arrow type. Then the question becomes, how do we separate the green ones from the red ones in real world? So the theory behind this is simply easy. We simply count the number of connections that each airport has, and then we simply compare these numbers with each other. So we see that the one on the left has 6 connections and is thus more interesting than the one on the right that has only 1 connection. So sounds like a lot of work, but luckily we don't have to do it ourselves. We just need to know what kind of information to look for. So once we know what to look for, we will actually then find it. So here we have something dated from 2016, the world's most connected airports. So then we just need to combine this information with the strategy of the company. So now we actually look for well-connected airports in Asia and in Europe. In this way, we find the Kunming Airport of China. It's on place 48, but in Europe you will find only 3 airports that are more connected than the Kunming Airport. In Europe, we find that the second airport of Istanbul is actually a low-cost mega hub. So let's go back to the equation that I showed you earlier. So it describes how likely any airport will get new connections. And as I told you, this is dependent on the existing number of connections marked with the K. But this is also dependent on something called the fitness, which is marked on an N. So it actually tells you that the more fit airports, the more attractive airports are likely to grow faster. So the ones that have been able to grow fast in the past are likely to have a high fitness value, and because of this are likely to grow fast also in the future. What we actually see here is that both airports of Istanbul have been growing very fast during the last 5 years. So what it basically tells you is that if you want to grow, then you go to Istanbul. So we have made some selections solely based on the number of their connections. So shouldn't we take other things into consideration also? Well, kind of yes, but the point is actually to have a very simple tool to choose the best locations. The most connected locations will have all the rest that comes along. So for example, we identified the Kunming airport. When we look at this location more in detail, we actually find that Kunming is the capital of the Yunnan province. It's also the gate to the Southeast Asia. It has railroads to Vietnam, Laos, and so on. It has the headquarters of large companies of the Yunnan province. It has several universities, so it has a lot of skilled labor. It's also a center of culture and of tourism. It has 4.5 million inhabitants and actually 6.6 million when counting the whole metropolitan area. And now if we look at Istanbul, it's the biggest city in Europe and it's the bridge between East and West. 12.5 million tourists visit Istanbul every year, and it has this international financial center project and has been able to recruit many big financial companies like Citibank and Merrill Lynch. Then we could also look at the city of Yunnan. We see it has a huge amount of universities and research institutes, a huge amount of skilled labor, and it has this high-tech center infrastructure money that has been able to attract these big international companies like LG or Volvo. So the point of all this is that just by looking at the number of connections, we get a quantitative measure that allows us to compare a huge amount of different locations and to choose the best ones from there. This method will give you a very good set of selection, and then you can go into the qualitative measures. But basically everything that you get out is very nice, but you can just find it so fast in this manner. So implementing strategy is of course not as easy as told here. There are many other aspects to also take to consideration. For example, you get permits. You need to have the flying permits to fly to these locations, so it's not that easy. But I think still in the end that these kind of approaches can be quite useful and they will make this task a lot easier. And then finally I would like to pinpoint that this is not something that I have invented on my own, in the sense that a lot of research has been done in the area of networks, and I'm simply presenting some major findings and some major tools that have come out from this research. Here are the references. Thank you all. I hope you found this to be useful. Bye.